So today we got the hard problem max chunks to make it 32. I really wanna go to sleep, so I don't know why I'm starting a hard problem, but I guess. So you are given an integer array and we split it into some chunks and we sort each chunk, and after concatenating the largest number of chunks we can make to what? Okay, I guess so. You wanna find smallest subarrays such that the subarray is sorted, and this screams and squared 2000. So I guess the logic is that, okay, so we re-index the values, or do we even have to, like, no, it's this max problem where max is the smallest integer that is not present, larger than 0 or whatever, right? So we start at the minimum, I think, and then we iterate, and then when what? I mean, it's an interesting problem, which I don't know if I have energy to do right now. Okay, what do we want to do is somehow, right? Okay, let's say, okay, so we will like dp number of chunks to split to have sorted first whatever, right? And then from smallest number, so this would be 0 and this would be 0 and then this would be like 1, and then this would be 0, this would be 1, this would, I guess, be like it's gonna be tough. Not sure if greedy would work, but max chunks to make sorted. Okay, so we wanna do smallest subarrays which are correct. So I guess we first sort it, and then if at some point we visit all of that prefix, we put it there, not sure if greedy would work, to be honest, because then that would mean we have linear time, which I'm not sure that would work. Okay, let's say for each subarray I compute this. Attack. Okay. Okay, so let's say we start, and then can we in linear time go left to right, and let's say we start with subarray here, and we check if it's okay, and then this one and this one and this one, so we just move the right pointer, and now we have that. Then we start from here, and we build this gigantic like a subarray sheet, which if this will be true, that means that the whole prefix also has to be true. So if this is true, then the rest has to be true, I guess. And then we can make the DP. I guess we need the DP because, I mean, if greedy would be solution, then this would be 1000 times more, or at least 100 times more. Okay, and how do we make the subarrays? Well, okay. Okay, let's say we do the first subarray, and now when will be the condition met? I know already, I know. So we will have the sorted array, right? And now we will have pointers here, right? And then we go through here, we save index in sorted array, and we put ones at those position, right? So I meet 2, okay, so I would put 1 here. I meet 1, then I do this, and suddenly my pointer moves because I have 1, and I am here. So I managed to get further than my position, meaning that I visited all of these. Great, that's a subarray, right? And then right, we continue, and when we start from here, I wouldn't actually even start here because like this prefix is not sorted, so I would immediately skip it and start from here, and immediately this would, we have that sorted, and then I guess, so it starts from this, and then that's, we assume this is sorted, so we also start our pointers here. Okay, that's fair. I guess this should work. I mean, maybe overkill, but I don't know, and I don't care. I just want to get this over with. So let's call it like, I don't know, chunk. And then, okay, so this gives us chunks, and then R, no or yes. Okay, and then let's call it like visited maybe, and we also need like vector int sorted array sort that's fair, like that, and then okay, and we need some sort of a map. Boss, and now boss of sar I is I. Great. So now what do we do? Well, we have seen we need like a pointer, right? So not sure if pointer can stay here, I guess yes. And now this array R is no, position of array R is 1. And now while pointer is under an and this pointer, then pointer plus plus. I guess I can just do no, I probably shouldn't do that. Okay, and now if pointer is over R, right, that's great news. If not, chunk 0 L if L and this if pointer is over R, that's great news, I guess. Not sure. Yeah, I guess that's what we wanted. So then we got chunk like this, and then okay, so let's say this will be our subarray. I mean, I guess we want it including that position, so technically we want to go from 1 up to I. And then we want to do if if j is 1 or chunk 0 j minus 1 and chunk ji, great, maybe another bracket, nice, then dpi is max dpi and dpj minus 1 plus 1 and then return dpn. Maybe something is wrong somewhere. Not sure. What the freak? Oh. Then why am I doing even all this? I guess because of that. Okay. Scratch my head, bro. Okay. 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 Not sure. Oh, ties are a problem, looks like. That's not great. Or is it? So chunk 0, 1, 2, 3, 3. Chunk 4, 4. Chunk 3, 4. Well, that's weird. What? What the hell? Oh, because, okay. Oh. So, R, array R, position array R. Okay, the ties are kind of a problem. Every time, but okay. Maybe it shouldn't be such a problem. Post pointer and then like post pointer 0 and then post pointer sarr I push back I maybe, or just post and then post at post point. What the hell? And then what am I doing? This is disgusting. What the freak? Oh my god. Oh, okay. Maybe like that. Okay, that didn't break, and then post pointer. What? What? Not sure why that's a problem. I guess that you have to reset it afterwards, but who wants to do that even? Ridiculous. I guess I can hold it every time. Okay, let's say I compute it every time here, which is ridiculous, but why not? Okay, that worked. Still some outputs on here. Let's see if I'm dog watering or what is happening. Okay, I guess fair enough. And now let's see greedy passes. Sliding window, are you kidding? There is no way this passes. Why you put 2000 when greedy passes? Get lost, brother. Get lost. Are you shitting me? That is ridiculous. I make dynamic programming and these mufflers tell me that greedy works with 2000. At least it's done quick, so I still can shower and whatever. SMH my scam. What a shit, man. I guess then I can throw away this chunk logic and this whole dynamic programming, and I mean, what the hell. Make 4 and throw this out, and then throw this out, then once we found the chunk, then we do ans plus plus and ls pointer, and then break, I guess. Still kind of slow, but I make it way easier here. What? If this is a chunk and this is a chunk, then that is a chunk too, so... Oh my god, bruh, hell no. Okay, so we sort expect. What? What? Oh. Oh. It's quite good. All right, I guess. Fair enough. Okay, so oh my days, even quasi-linear time is not optimal. That is crazy, dude. Are you kidding? I mean, good logic, I guess, but... Okay. It's really this simple. There is no way a hard problem is this simple. Like this. Oh my god, this is the easiest hard problem of all time. Greedy solution. Okay. Intuition. If AN is a chunk and A1, AN is a chunk such that NM, then AN plus plus 1 am is also a chunk. Therefore greedy is optimal. When is a prefix a chunk? Last thing we have to resolve is when is a prefix a chunk. If if maximum of that prefix is smaller than or equal to the minimum of the suffix ending at the next position, or the prefix is the entire or the prefix if maximum of that prefix is more than or equal to the minimum of the suffix ending at the next position, or the prefix ends, prefix is the entire R, then a chunk ends at the current position, and we can increase the answer approach. We pre-compute the suffix minimums and then keep prefix maximum in a single variable and iterate over array, checking the condition. On, since suffix minimums takes on, and the forward pass does only O1 per position, which gives therefore it takes on in total. On, since we store the suffix minimums and a couple of extra variables. Okay, I'm brain dead. Goodbye. I wanna go to sleep so bad. Goodbye.